Good evening, everybody, and welcome to vBrownBag, the weekly IT video podcast where we bring you experts in the wide world of technology to talk about their favorite topics, kind of like show and tell for nerds who want to learn something new. Tonight, we are going to be decomposing Terraform for multiple clouds with the CEO of RackN, Rob Hirschfeld. Rob, thanks for coming onto the show.
Chris, it is great to be here. This is one of those topics that has had me pulling out my hair for years, and it's still really challenging. So I think we're going to have some fun talking about that, and then maybe some infrastructure as code along the way.
Awesome. So, I've actually been getting into a lot of Terraform recently. I spent my Christmas break going through the Terraform up and running book, and finally diving into all of the corner cases that I was like, okay, well, what if you wanted to do this? And what if you had multiple clouds? And what if this and what if that? And so this is the perfect way to kick off 2023. But before we get into all of that, let us get into the housekeeping notes. If you want to get in on the conversation, you can at vBrownBag us. I will be paying attention both on the Twitter sphere and on Mastodon. So if you at vBrownBag on Twitter, I'll be watching it. If you at vBrownBag at fastodon.org, I will also be watching that as well. You can find Mr. Hirschfeld at Zehicle at hackyderm.io, and you can find me, of course, at Mistwire at fastodon.org. Or if you just Google Mistwire, I'm the first 5 pages of hits, which is something that me and Rob were talking about why I chose Mistwire before the show got started. Where did Zehicle come from?
Zehicle was a boy. There's an interesting backstory. I was really into electric cars before you could buy electric cars, which meant that I did an electric car conversion.
Oh wow! So you were really into it.
I was really into it. I converted a RAV4 into a electric car and ran it off batteries for years. And then my oldest kid drove it to school for another couple of years. We got, I think, 6 or 7 years of life out of the converted RAV4. And I did it actually as to seed the idea of vehicle to grid. So I had this idea of building applications that would help people know when to charge their cars when the power was cheap. And I talked to people at GM. I talked to the person who ran Austin Utilities about this, and Zehicle was going to be the name of the company. That was the starting point for Z for zero and vehicle. So
vehicle, right.
Zero vehicle. It's funny. The guy who ran the power company, he said, and I asked him, I said, I need an app to know when it's good time to charge the car. And he goes, at night. I'm like, what do you mean? He's like, at night. You don't need an app. The windmills run at night. Charge your car at night. And I'm like, no, people need an app. And
yeah, regardless of if it, like when the lights go low, no, you need an app to tell you that the lights that the sun has gone down.
So it's one of those classic. But to me, there are certain times in life when you learn this huge architecture lesson in the simplest possible way, and you sometimes the simple solution is a clock is sufficient to tell you the information that you need. You don't need a lot of algorithms for it. But that's the Zehicle comes. So I bought the .com. I had the Twitter handles. There's a whole bunch of stuff. And as I built up that brand, I just kept it rather than there's a Rob Hirschfeld in places, but that's people don't necessarily know how to spell Hirschfeld on site, and so
I had to triple check to make sure I got it right when I was typing it out. I was like, okay, there's a C in there. All right.
Once you've got 15 years in a brand like I am with Zehicle, or you with Mistwire, it's more people know me that way now than they actually know my last name. So it's all good. All good.
Awesome. Cool. All right. Well, I will relinquish the share, and if you want to pop yours up, then
I would be happy to. And one of the things I will do, let me see if I can do this the advanced way and get portion of screen, keep things a little bit more interesting. And how's that? Does that look pretty good from a size perspective? I can go a little bigger. That's about.
Yeah, and we're recording this in high resolution, so it's
perfect.
Go back to you popped one down. Go back up one up.
Like in the screen size?
Yeah.
How's that?
There you go. That's it. That was
Perfect.
the one that you had originally, right?
Yeah, I think it was. Yeah, it's what it gave me by default.
Cool.
And what I'm showing right now is Digital Rebar. I'm gonna work from our product, which is called Digital Rebar. And I'll talk about that a bit. We are gonna work towards and starting from Terraform and Terraform's limitations. So I'm definitely not going to turn this into a sales pitch. But what we do as an infrastructure as code platform is create this type of abstraction. And one of the things that I learned in dealing with a lot of companies and talking to a lot of people about Terraform is that everybody has been building up their own ways to solve this problem. So we're going to really talk about this sort of generic Terraform problem. And I have, there's some resources. I'm not going to go back into slide mode. I do want to keep this conversational, but I've done presentations about infrastructure as code and scaling infrastructure as code, sort of, the principles of it that pull things together. So you can go, I would suggest if somebody's interested in sort of the foundational pieces that are going to make that I'm going to gloss over, like where Terraform fits and why Terraform is so hard to scale. It's easy to start. It can be really hard to scale. But we actually have a presentation where I walk through how all of these things fit together using the same examples that we have here of how do you build a workflow? Because the thing that's useful, actually, this is a useful example. Terraform does one thing in your journey of automation, right? It's a provisioning tool. There are things that you want to do before you do provisioning. There's things that you have to do after you do provisioning. There's things that you might actually do in the middle of the process to collect information. And so Terraform can do some of that. There's places where, it's only part of a process. And so we're going to talk about Terraform a whole bunch. It's always useful to be like, oh, okay, wait, I need something before that or after that, or if you want to do drift detection or things like that, there's ongoing process. And so we have some talks that talk about how all this stuff works from a sort of a foundations perspective.
Awesome. I'll get the links for those and pop them into the show notes for the recording so that folks can check those out as well.
Excellent. And then as we need, I'll bring up some of this other swim lanes of how we're sort of scaling the automation on these pieces.
Nice.
Because this is right. There's the concrete stuff that we're going to talk about how you do multi-cloud Terraform, but there's also the ideas of actually doing a system that runs Terraform for you and then does configuration after the fact, or inventories the machines. Does that make sense?
Oh yeah, absolutely. No, cool. This is going to be awesome.
Let's start with the Terraform, and I actually said in Digital Rebar I've already spun up a whole bunch of clusters. I've used Terraform to do it. Got a whole bunch of stuff that we can pull and play, and I'll actually walk through a Terraform build process in Digital Rebar in a minute. But before that, let's actually show some Terraform. Start there, and we'll talk about why this is really hard. Okay, I'm going to zoom in a little bit if I can. Maybe I can't. Let's see. Where is Zoom in?
Are you on a Mac or a PC?
PC.
If you
I'm doing my control. Yeah,
control plus.
I am. Oh, Control Plus. There we go. Thank you. It's using my Control scroll pad. All right.
Yeah, I always do that for browsers, and then I forget that in VS Code it's not, and you have to switch over. If it was Mac, it would be Command Plus.
I wouldn't even think about it in a terminal. It's all muscle memory.
Right. Exactly.
All right. So here's some Terraform. This is Terraform that is AWS specific Terraform. And Terraform is straightforward in that it follows some very consistent patterns, and that's great. We're going to actually talk about where the patterns break down, because they break down pretty quickly. But they're all you're going to have a provider. Good practice is going to be to lock the version of the provider, right? Require versions have some good standards, and this is useful. I'm saying this because if you want to do we're talking about multi-cloud Terraform, which there is no such thing. So that means that you have to do something around Terraform to make it multi-cloud. And your head might be exploding at this point, because you're like, but Terraform does all these clouds. It does, but the plans are different. So it is a multi-cloud tool, but you can't take a plan that works for Amazon. This is what we're going to spend an hour talking about, right? You can't take a plan that works for Amazon and then apply it to Azure or VMware or Google or Oracle, or I've done with 6 or I think 7 different cloud infrastructures using the same APIs, all driving bespoke Terraform or generated Terraform. Right. That's the punchline of this. Is I'm going to show you how we generate Terraform in a consistent way that runs across clouds. So you have to, but to do that, you actually want to build good Terraform. And so we'll walk through all those pieces. Right. So you have standard stuff. It's even worth noting, right? Even the region you're using is plan specific. So if I wanted to build a cluster that spans multiple clouds, I'm gonna have to do certain pieces of work about that. Right. Injecting I have a credential injection. You need things like, okay, here's my key pair setup. Every cloud does key pairs differently, a little bit differently. So if you're going to build, I'm assuming you're going to build and inject keys as part of any Terraform process, any provisioning process, really. You're going to need to be able to manage the keys however the cloud expects it to happen. There's no Terraform standard for key injection. This is where, if you're used to doing Ansible, Ansible is a little bit more like, oh, we've taken add key and then made it multi-platform. So you've got a DSL that says add key and it works. That's much harder to do with Terraform. Okay. Right. So you actually have to know how you're going to build a key pair for the appropriate cloud infrastructure that you have. Right. Okay. Locals block is going to be is local variables. Since we're building the same, I'm going to show you how we decompose these pieces, but it's really handy for anything that's more than a couple of lines long, like our cloud init script. I used to do this inline in the machine blocks, and it's just so much, it gets so bulky. I pulled it out. So I actually use locals in a script like this to have things that are going to clutter up my templates otherwise. And what you'll see here is this is digital rebarisms. So our cloud init script here fundamentally does what we call join up. So after the machine boots, it's going to automatically join in digital rebar and then allow us to run provisioning configuration workflows after that. So it joins up. I'll show you how all this stuff works. It's sort of fun. Awesome. But anybody doing any Terraform, right? You need to have a cloud initialization sequence. Just spinning up machines is not going to do you much good. So every cloud is different, okay, in how they deal with these initialization. They all have them, but they're all different. I'll show you a couple. Like Linode is totally different than others. And so you have to account for, wait a second, Linode doesn't actually do a cloud init script at all. You have to run what they call a stack script. Okay. That's their word for it. Right. Are you following so far? So this is basically a standard header, standard in that all Terraform provisioning is going to have a header like this, but they're not all
going to be, this cloud init script wouldn't work in an Azure environment or right. Yeah, no,
totally. So I have an Azure one and I have an AWS one, and we'll build and show some other ones. That's because that's the point of what we're doing. But I wanted to show sort of the framework that we're then going to be tearing apart. Because what we're going to do here is we're going to say, all right, this is great, but what I really want to do is have this whole part of the code for AWS is a standard block for AWS that I should be able to reuse in a generic way. And so part of what we're going to be doing is to make these plans work is we're actually going to be piecing them back together. And you can see, because I left the codes in, this is taken from a generated template. But you'll notice that each template piece, it actually tells me where it's coming from.
Where it's pulling from.
So I can come back through and see it. Yeah.
I think that Graham actually just teed up your next talking point, because he said, is there no way to check which cloud you're running in and then abstract up?
That's fundamentally what we're doing, but in a sort of tricky way. I'm trying to bring up here's Q&A in chat. Okay, good. I got the windows up again so I can see them.
Oh, that's fine. Don't worry about. I will.
You'll be the interpreter.
Questions. Yeah. Don't.
No worries.
Don't worry about that. I'll. If something good comes in, it's not going to escape us.
Yeah. No. It's an important question, because fundamentally this is what we spend a lot of time asking ourselves. Because let me pull this out of the way and I'll show you what it looks like in Digital Rebar. Because this is the goal. So what we want to be able to do, I've been talking about Linode. So if I wanted to build a Linode cluster, LAN-ODE cluster, I'll call it Linode 1. Then I'm just going to build a standard cluster. So it's base. There's a whole bunch of stuff I'm not going to walk you through at the moment. But we have something called a resource broker, which is this abstraction concept. This is actually where it gets the information to distinguish. So what we have is a way to build a cluster, and I can send it to a broker. The broker figures out how it's handling the uniqueness of each infrastructure. And notice, like I have ones for Azure, Phoenix. This is PhoenixSnap, DigitalOcean, AWS, Google. I have an Oracle one. I don't think I installed it on this. But if I pick this broker, pick a number of machines, I can set some post configuration, like what pipeline I want it to run. I can set icons that I want. Let's see, let's pick, I guess, green. This helps me distinguish the different systems once they're built. I don't want to tick it. And then once I start this is the abstraction point. So what we know is that people doing Terraform or any type of work, they don't want one machine. They're doing, even if they only ask for one machine, they're really building a cluster. A Terraform plan is a cluster. Right. And so this is the abstraction point. It literally is going through and running, it's running Terraform on my behalf. So it's building that up to Graham's question point of like, how do I create this abstraction? The way we've done it is we treat clusters as a generic thing. They don't have to be Terraform, they could be anything. And then we pass a request to a resource broker. The resource broker translates that request into the cloud specific Terraform.
Into the provider you want it to target.
Correct. And that doesn't have to be Terraform. It could be anything. Bare metal, it could be just a bunch of machines. It could be something out of a pool. That became our abstraction point in how all this stuff works. And that's exactly right. We're abstracting on the backside. But the point with this is that when you look at the Terraform doesn't give me if I can grab my, come on.
Oh, don't you hate it when that happens? You can't tell where the edge is, so you keep grabbing the file. There you go.
Here we go. I got it. So the challenge is, and this is why I'm going through this carefully, is that when you look at these things, these are not standards. Like AWS security groups are a unique thing. No other cloud has this security group concept. So this ends up being its own block. And I can't deal with them generically. I might have somebody say, you know what, I have my own security group definition, use mine instead. And you have to be able to say inside of this, override the default one that you're building and let somebody put whatever they want. Because right here, what you'll notice with Terraform, I'm building an AWS security group as a resource. And I'm going in and defining a name and a prefix and ID, right? And all this is cross-referential, which is the right thing. It builds these up. These are actually populated from variables inside the cluster definition. So one of the other things about Terraform is that if you start embedding your things like port mappings inside that plan file, then what you've got, if you want a copy of your Terraform with different variables, different ports, say, well, now you've got two plans and you're storing them differently, even though the only difference in them is that they might have different ports in them. That's a complete failure from a scalability perspective or an infrastructure as code perspective. So you end up needing to have some way to inject, here is my ports list. And that could be a variable injected into Terraform. That's a valid way to solve the problem, and having inputs in Terraform, but then your Terraform becomes increasingly codey. And if you look at our templates, you'll see that we use Golang templating behind the scenes. So this is actually generated in Golang templating. It's got to be generated somewhere. This is the balance, yeah.
So if you wanted to have multiple, traditionally people say, abstract it out so that you can have, like, for example, the security groups, your froms and your two ports. You use variables so that you can add and change them if you want to, like if you've got what have you, a UAT environment versus a production environment. But you're saying that that's a detriment?
It's a detriment if you're coding them as directly in the file like this. You're going to end up with, if you have copies of the files. So right, if you're like, oh, here is my plan and it's for UAT, here's my one for dev, here's my one for prod, and they're identical except for this one stanza. That's not going to scale very well, because it's really easy for somebody to say, oh, I fixed the dev one. Did I remember to make the copies in the other ones?
Gotcha.
Copied files are copies. They are not regenerated from source. If I'm doing infrastructure as code, then I'm actually trying to build immutable templates.
Right.
So me writing a Terraform template when any manual touch on that is a failure from my perspective as an infrastructure as code process.
Right.
Right. Ideally, you don't even want to care that it's Terraform. Somebody could show up and say, you know what, I'd rather, my team really likes Pulumi. Can I use that? Or can I use one of the cool, if we have time for it, I have some cool demos where I've been wrapping the AWS CLI and being able to be like, oh, I can send a CLI command as part of this because it might not be exposed correctly. There's really fun things about that. But that's so, right, this is why it's fun to sit down and look at the Terraform and say, all right, well, what's going to not work in my Terraform? The other thing that you'll find is that a lot of things downstream from Terraform, like cloud economics, cloud cost just management, or things that are doing governance are actually using tags. And so you need a way to be able to have tags. If you're building Terraform, any cloud infrastructure, without thinking about tags, you're actually missing an important part from an enterprise governance perspective.
Right.
Because things that aren't tagged correctly, a lot of systems are starting to delete them by default. You don't have the tag, you don't have the cost center, you don't have the sign off flag, it's out. Which they should do.
That's the first Lambda that we usually write is if something is completely untagged, you've got 24 hours to get rid of it, or otherwise it gets deleted, or to add something to it.
And so this is where the discipline of having these, and you could add linting. Like one of the things we added was automatic linting, and you can actually inject linters or linting specs into the running process. But part of the nice thing about the templating is that you can start saying, all right, it's that my templates are going to build correctly generated Terraform, which is hard to do if you're not, if you're hand rolling it. And then things get really, really interesting when we actually start building a machine. In this case, you'll notice we're actually using a variable here. So I'll show you what this looks like in the thing. I didn't realize I was doing this. Normally this would just have an array of the names of the machine. That's what that is.
Okay.
And then I've got all the, right, I've got to have the AMI, I've got to have the instance types. We're back to, generating a whole bunch of tags, which, is important. Cross-referencing the key name, security, getting our security groups pieces in here. This is where you might override it if you didn't want it generated. Oh boy, and don't even get me started. If you don't do a destroy correctly, these things are gonna hang out. Which is a risk, right? If you write these things. And then this is where, instead of having a big block of code, we have
referencing the init script from up above.
We reference this, and then that's it. This is AWS Terraform is actually much simpler than other Terraforms.
It's a lot easier than Azure's Terraform.
Azure's Terraform is why I picked it up as the example. Is this my Azure one? This is Azure. Yeah, when you look at Azure, right? Yeah, here's once again, standard block. So here's what we're doing is we're injecting a whole bunch of variables. So here's the names. So I can refer to things. So there's all that information that we injected in the cluster. When we built it, it actually passes it into Terraform. So we have it all available, which is super, super handy from that perspective. So I can write Terraform counting on certain amount of information. I don't have to inject it all in the template. But yeah, so to make Azure work, you see, I sanitize these. It's the same thing. I've got my init script. This one's more complex because, oh my God. Sorry, I just have to rant for a moment. It not only is Terraform different for each cloud, the cloud init in different clouds is not consistent or sane.
Right.
So this actually, all right, this is where platform teams and ops teams are worth their weight in gold, or the type of stuff we do where we're trying to eliminate toil by fixing stuff like this. Azure's, the V1 cloud init, so cloud init's a big JSON blob. The instance ID in cloud init, they have a V1 and a V2 block section, are different. So if I was going to look up the instance ID in Azure and I pulled it from the V1 block, it would be incorrect. Whereas it's in the version 2 one, it is correct. So I can't tell you how many hours I spent troubleshooting this. Literally, so this comes in, and if you're on Azure, it's smart enough to inject something in Cloud Init to rewrite the friggin' IDs based on the correct ID in that block.
Oh man, that sucks.
And block 2 is not consistently implemented across all clouds. So block 1 is actually more reliable. But you'll notice it's like, not only is it incorrect, they actually are like, you know what? We couldn't decide if it was instance underscore or instance dash. So it's both. Right. I mean, so it's not even like, and this is where I'm like, to an extent, I give Terraform a pass, because there is no way to create a consistent abstraction across all these clouds.
When the cloud itself hasn't provided a consistent mechanism to access it. Yeah.
And they have no incentive. There is no Azure person talking to an AWS person who says, you know what, I think our customers would really like it if our API is converged. It's never happening. So yeah. And that's what I love about this topic. It's like, all right, what does it actually take to do this? And that's why it's an interesting detail to come back and start working this out. And then making it so you can use it consistently. And then Azure, like you were saying, we have to have a resource group, which is awesome. Resource groups are great because they bundle everything under one heading, and you can delete everything together, but it's different, right? You have to create a virtual network. You have to create a subnet. These subnets all have to cross-reference each other, right? They have their own security group, which is a different syntax than the Amazon ones. So you have to have a whole, you have to have that. Same thing. If you're gonna try and generate it from a variable, it's going to generate differently than the Azure one, which is different than the next one and different than the one after that. Yes, and it is dog's breakfast is right. This is why it's a good topic though, because it is the tool that people use to build this stuff.
Right.
And for us, we're trying to help companies create more standardized reusable process, because right now they've got dumpsters full of Terraform plans that are copied from other dumpsters full of Terraform plans, and control. It's a really hard thing to get back out of. And then I'll show you something in Amazon that we had to add. Another good story. But yeah, so this is the, I won't dwell on the Azure one too much because it's complex. Here's another one. Here's the Linux virtual machine for Azure. Fine. But you'll see it actually, the network interface IDs are defined in a different way. The key is actually here, not as a reference item. So I have to define it here, not as a resource. Right. The whole way you source images is totally different. The init data has to be base 64 encoded out of a, right. It's a lot.
Yeah, I'll be honest. I've not spent a lot of time provisioning Azure. Obviously, I spend more of my time in AWS, but I have just provisioning one virtual machine, like in a default environment. For AWS, it was like 5 lines of Terraform, and then for Azure, I think it was like 20 or 40, 20 to 40 lines. I was like,
the funny thing is I understand the Azure spec is, and Google's similar. Like, I mean, we did this for all the clouds. And so when there's sensitive information in these files, so you have to turn on debugging, but anytime we run, these are just debug output that I turned on to capture the plans so I can see what the plans look like. But yeah, it took a lot of time to go through and map out how all this stuff works. I'll show you why it gets even a little bit trickier. I'm trying to think of what the next thing to show you that makes sense is. Let me explain one more thing, and then I actually want to show you. So let's see. This is the one with all the digital rebar decorations in it, all the variables. And let's see. So this is, and I'll show you the templates that are used to generate this, but I want to explain one other thing that I'm super proud of. This took a long time to get working correctly. And it's really useful. So inside of our Terraform, we will automatically generate this local exec. And I usually would tell people to run away from local exec like the plague. It's really actually pretty scary. So local exec means that I'm running Terraform, and then after the Terraform runs in the cloud, do something on my local machine.
Right.
Which people use in all sorts of weird ways. Remote exec is even worse. Because it's like this weird, not quite Terraform or Ansible thing. But we figured out a way to use local exec that actually is scaling for us really nicely. And what we do is when you create or destroy in Terraform, we run a synchronize command. And what the synchronize command does is it actually tells Digital Rebar to create or destroy a machine entry for all the machines I'm creating in Terraform.
A machine entry in your
Digital Rebar.
Okay, gotcha. Okay.
So what it does is it'll create a machine entry before the machine's actually created all the way in the cloud. And what it does is it does it, but it passes in information about the ID, the name of the machine. Notice, and these are from Terraform's own variable definition. Right. So the address, the public address, the private address, what workflow we've asked for, that's our internal stuff, the pipeline, the tags that you were given, the icon, all that stuff gets passed into this synchronize command.
So
destroys
it's self-documenting and less prone to error.
It's actually even further than that. When the machine joins up, this is the magic we added with digital rebar. When the machine joins up, what it does, assuming I can grab there's my space to grab. When the machine joins up over here, let me do one because that'll actually show it. We'll do an AWS2. Let's see. And you'll notice like we have brokers like for East and West, so I can actually provision against different ones. All this is good. Let's do bright reds to make it easy to find, and setting. Okay. So this one, now it's running. Now we're running through the process. We're building the cluster. The cluster is going through and making a call to the resource broker. Let me show you the resource broker. Here's that Amazon broker. If I look at what it's doing, I realize I'm flashing through really fast. I'll scan in a little bit more. But this will be right. So it's basically running our Terraform request. So this is my Terraform being built. And down at the bottom, it's giving me live updates as it's creating stuff in Amazon. So all that's happening here is as Digital Rebar is running Amazon or running Terraform on my behalf. So it's generating Terraform. Right. I showed you the file it's generating. It's running it now on my behalf. The way this works, it's doing it on the server. The way this works, we're actually getting a live update as it does that work.
So the broker is running the apply, which is why the local exec works, because the SH is on the broker.
Right. And then, so it ran that execute. So I call this thing, what did I call this cluster? This is AWS2. So if I come over here, what you'll see is I created machines called AWS2, 0, 1, 2. You can control the naming. This is the defaults. But so I've created this machine called AWS2, and I used, this is where it gets interesting, I actually already set up all that information that I collected for the machine. So the machine's not even provisioned in Amazon yet, but I've already got the details back from Terraform for this cloud. And you'll see some of them are, these are general. So all clouds have an instance ID and a v4 address. There's also ones that are Amazon specific. Those will show up as it provisions, so I'll have more detail. But once that machine joins up, it's going to register itself. It's doing it now. The cloud IDs match. And it says, oh, I already know who you are because I can match those IDs. And then run through so now it's actually running a discovery process on the machine itself. And what you were just watching was it collecting all sorts of information about the system. Which we do on it's a completely generic process. So it's cloud agnostic. But now what you'll see is it's running through a pipeline of configuration workflow on that machine. All the machines are doing the same thing right now. And this is settable. So Terraform, yay, got me a good standard way to do AWS. It didn't give me a standardized way to do a whole bunch of post-provisioning work, which that join up and then process does. But without that exec script, you don't have the ID and the IP address. Those things are really hard to discover.
Right.
And so we do have a script in here that's part of this process. Here, I think I can actually show it. It's hard to do everything. There's actually a script in here. Let's see. It gets injected for the cloud. Let's see, it's under Go High. There's actually a cloud. Oh, it's already gone. We're in the run book. During the discovery phase, it actually does additional like cloud API, detects the cloud, figures out what it is, and pulls additional data back from that process. Because every cloud's here. I'll show you that. This is fun. I mean, it's just setting up the machines at this point. There's an interesting parameter in the product. This isn't Terraform, but it's related. cloud. Let's see, cloud, init, nope. Somewhere it's in here, cloud placement, cloud meta APIs. This is when we talk about multi-cloud, this is one of those interesting things. Can I make that bigger? Okay. For each cloud, it's not just enough to do the Terraform differently. We actually have to be able to say, okay, for Amazon, my meta API URL is this. For the type, availability zone, IPv4, host name, like we're getting some of this from Terraform, but it's not always reliable. Right. And so each cloud, it actually goes through and does that curl and then returns it.
And then for Azure,
and then Azure, DigitalOcean, Google, Linode, Oracle, and this is user extensible. Here's an additional level of, oh, wait a second. You notice how AWS is last on this list? This isn't an alphabetical list. Sorry, it's almost so sad. All of the clouds actually simulate AWS's meta API. Then don't always do it correctly.
169.254 pull.
Correct.
Okay.
Right, they don't all, most. Like if you look at Linode here, Linode is actually doing a cat JSON whatever, because they don't have an API like that. But like they're not all the same, but they will respond to the Amazon one. And so if you were using this to detect which cloud you were on, you would get fake AWS results, which was happening to us.
Oh, geez.
Because, right, so you're like, oh, why does my Google Cloud keep thinking it's an AWS cloud or failing because it thinks it's because the APIs will answer.
And you were getting back like the same IP address for all of the instances or something? You said fake.
It's interestingly, I was getting the right IP address, but the system was saying, wait a second, you are not an AWS type instance, you're a Google thing, and that is a cause for it to freeze. We consider that an error. So if my system here, so you'll notice, like when I'm going to look at an Azure one to give you an example. I actually have a parameter in here that says I am an Azure cloud. It's important. Well, if I run my cloud check and pull all the meta APIs, and one of the things it does is it returns like an Amazon AWS, it's going to match. It's going to say, whoa, wait a second. You are Azure, not AWS. I'm confused. And from an ops perspective, confused is bad, and we stop. We always confused is bad, and we always stop. It's a cardinal rule. Like we have no retry. One of the things that's distinctive about the way we do this stuff, we have no retries. There are no automatic retries in any of our infrastructure as code automation, because retries are the symptom or can mask problems, and so we don't do that.
Sorry, one of our attendees is an old colleague of mine, so I have to make sure that he knows that I know he's here listening. Hello, Roger.
This was an early architectural advice I got in my career, and it's awesome, and I love to pass it on. This comes out of the realm of civil engineering, but it's useful. So in civil engineers design stuff that kills people when it doesn't work right. Right, roads, very dangerous. And the number one rule for civil engineers designing successful systems is confused drivers are dangerous drivers.
Yep. And
so it is really important in anything when I design stuff to sit back and be like, okay, what does confused look like? What does a confused driver look like? And so, yeah, so our systems and our automation's especially picky. And so if something's not going right, the automation is always set to stop. We spend a lot of time making it easy for it to restart where it was. So we're good at like, oh, I'm halfway through 100 steps, something broke. I can just stay retry. I can decide to retry, or I can fix and continue. But the system by default just stops.
There's a fascinating article in the same vein that it's fairly long. If I find it, I'll send it to you. It's if civil engineers created bridges the way that software engineers create software. And it is hilarious. It is heartbreaking. And you will be nodding the entire time. The author was hysterical. I almost peed my pants. I was laughing so hard at this thing. If I find it, I'll send it to you.
These are, you're looking at the stuff we're showing is, it's a real failure of, consistent applied standards. And then you end up, if you're not careful, you end up coding to, like the metadata, the cloud init bug I was showing you. It's like, if you coded that without, like we made a choice. I could have just tried to pick it up, the incorrect version. I actually made the choice to write code to fix the file so it was correct. Because I felt like that was the least harmful strategy to fix it. There's times like we just have to be like, all these are different, write a quirks file and move on. But
yeah.
Boy, I have a lot of clouds provisioned. Yeah, I'll show you the destroy. The destroy is fun on the other side of it.
There we go.
But right, so the nice thing about the clusters, part of what I can do with clusters here is I can turn around, and if I delete them, there's stuff I'm not going to explain in the middle of this, but we actually have a cleanup process that runs the destroy and is basically calling the provision, but with a destroy flag. And so it's going to go through, run my Terraform destroy, and then tear that cluster down. It's sort of handy, right? Because I should show this. It's actually storing the state file, the lock file, and the state file are being stored in the cluster. So each cluster, this is part of scaling creating a Terraform runner. Every cluster will inject its data into that Terraform plan and then also store the Terraform. So when I'm running all these, building each cluster, part of what I'm actually doing is storing the state files for us.
The state file and the log file is in the actual instances that you provisioned. It's in the cluster itself.
It's in the cluster, right? Because cluster is a stateful concept. So for the life cycle of this cluster, this is cool. So any one of these clusters I built, I could actually run lifecycle against. Here, I'll show you the Azure one. Right, I know which machines are in the cluster. Oh, here, this is fun. So if I wanted to run, say, a Ansible playbook on these machines, I know what they are. I know where they are. I've injected the key. I actually have a process where I can run Ansible apply. I have a standard safe template already wired in, so I can hit apply here, and what it's literally going to do, it's going to install it's running Ansible apply. This cluster doesn't. I didn't switch it to the thing that I had Ansible pre-installed, so it's installing Ansible, and then it's going to use the list of machines I have to build an inventory file dynamically, and then it's already done. And then apply, then it runs my playbook.
Nice.
Because I have the data, right? This is the neat thing about this cluster concept and having machines associated with it. I actually can come back through and say, oh, wait a second, I want to run additional lifecycle. Same thing is true. I could go in and do a drift detection. Where's my drift? There's drift detection. And if I run drift detection, it's going to run Terraform with plan and a plan event, and then it's going to basically, I can put that on a timer and then run that, right? These are what we call blueprints. And so their infrastructure is code automation. that I can apply in a queue as a queued operation. And then there's a whole separate, once again, I'm here, I'll show you what this looks like. But this is the different type of thinking. It's like, yeah, I got Terraform, I built a cluster. Nobody ever just builds a cluster. You always at least destroy it. If it's up for any length of time, you really better be doing some type of drift detection on it, which means reapplying your plan against what happened, likely on a certain time period. And so here it's saying, all right, take the state file, rebuild the template. Do they match? Great. If they don't match, it's going to throw events that I can track and alert people about. Or I could say, hey, I want you to clean up or reapply. There's all sorts of things I can do once this has happened. So there's a separate part of the product that does, let's see if I can show this well, so for example, I already have a cron trigger that every night does a drift detection, runs that same play I showed you, and then it'll send an alarm that I can detect. Same thing as I don't like having machines left over, so any unlocked clusters automatically get cleaned up every night. So if I forget to clean up my clusters at the end of the night, they always get cleaned up.
After your demo runs.
After my demo runs, yeah, I can do that. There's actually a button. So you can define buttons that do, it's basically the same thing.
It's a little bomb icon.
Little bomb, yeah, it just crushes everything. But same, so we have standard stuff behind the scenes that does it. And this is anybody who's building Terraform, and I actually, even for dev, right? The number of times I've been like, oh, oops, I left a whole bunch of clusters running. What's going to happen? It's really nice to be able to come back and say, all right, I have a point that I can point to that says, hey, look, I ran this cluster. I built this cluster. I can go look at it, see what's happening. And because this is in it's digital rebar software, so we don't run a SaaS. This is like your own endpoint, but it's still a shared API endpoint. So you can look at somebody else's resources, see what's provisioned, and then figure out who owns it, what they're doing with it, if something's changing with it. That's important, right? If you're doing Terraform from your desktop, it's great to play with. I build stuff from my desktop all the time, but as soon as I can, I get out of that mode into this.
Yeah, not for production.
Right.
Awesome. Cool. All right. Well, we have 5 minutes left, so I wanted to make sure that what's wrong?
Oh, I'm using up all my time. What did you want to make sure?
No. I just want to make sure that if anybody had any questions, or if we wanted to have any kind of final thoughts, or if you had an awesome thing that you wanted to show in the next 5 minutes.
I will happily take questions. I do want to show the flips there. I do want to show how all this stuff stitches together, because I was running. I'm running my mouth instead of showing how it all fits together. So let me try and do that in 5 minutes.
We can go a little bit longer if you want to, Rob.
Okay. So here's the thing that gets interesting. What I showed you in that Terraform file is actually broken into different templates, right? Each cloud has their own one. So I could have put in Google, Linode, whatever. And you'll notice, like Amazon, actually, we have a linter for it. But that AWS Init for us now injects, this is data coming out of Digital Rebar as part of the injection. So this builds that file up by injecting that information. But you'll notice this is just the one. Same thing as this is the instance file I have. And so this one's looks a little scarier, because this gets injected into another thing. I'll show you what that looks like.
So this is the templates that the broker runs off of when it's creating the Terraform to then push into the cloud provider.
Exactly.
Gotcha. Okay.
And then so all of that is actually defined, in a parameter. No, in a profile, sorry. So this is where the magic, the multi-cloud magic happens. So if you look at this definition for AWS Cloud, it's a resource because it gets included into other things. What we have to do to make this multi-cloud is we have to come back and specify all of the things that are AWS-isms. Right. So it's an AWS instance. The private IP address is resolved as self.private IP, which is different than other clouds.
Right.
So you can't just assume that you can look up the public IP address or the private IP address or where the tags come from, or even what the friggin' ID is different in each cloud. So what we have to do is you have to say, all right, I have to map these core things into lookups inside of Terraform. And then this is where you get to say which files you want to include. So if you had your own files or you want to add something in, you just create an override for this variable, you add it into the list, and then it generates the Terraform plan. It ends up being pretty straightforward once you have the pattern.
Yeah.
But if you close this one and say, look at the Google one, right, you have to go back through and you have to say, okay,
it's not self.id, it's self.instance ID.
Right.
Yep.
Exactly. You're catching it. Look at the IP address. It's network
it's
interface 0, whatever, right? If you look at the Linode one, Linode doesn't have cloud in it, so it actually has a stack script that has to be injected in that's different, and it has private IP. They're different. So what we've had to do is, for all the reasons I laid out, we then had to go and build these templates that were based on each cloud, then capture that, right? Capture the data back and then actually inject in, oh, wait, when you're looking for the cloud ID, you need to look it up using this path instead of that path to create, right? This is why it's such a fascinating topic, because we've had to go back through it. Now we've done enough of these that's a pretty consistent, like I know which ones I need. But even so, right, I only really need ID and IP address to make all this stuff work. Once the machine is joined, then I can treat it, we've done a ton of work to make, provisioning processes across different operating systems incredibly generic. So I can do all that work. But yeah, we've really gone into just what it takes to build a Terraform file that is cross-cloud, and then abstract it up a level so that you're actually pulling out the pieces that you need to then create generic automation on top of that. Yeah, and Graham, that was my joke about the cloud providers have no incentive to make it easier to switch providers. It is not their, they're
not going to cut their own throats.
No financial incentive.
Right. Exactly. Awesome. Well, I'm not, any last thoughts? Graham, was there any questions? Greg, if you wanted to ask any questions, feel free to chime in. I'm going to jump over to Twitter and Mastodon real fast, just to make sure that there's a bunch of people liking the talk, but not no questions.
We covered a ton of material. And I have some other videos if you want to see this broken down. I actually did one where I built the Oracle version of these templates from scratch, and you can actually walk. You can watch me go through from handcrafted Terraform into templated Terraform, if that's interesting to you, and sort of why that's about an hour video itself.
Yeah, absolutely. Let's shoot me the links. I'll send you another email, and what we'll do is we'll stack up the links that complement this talk, and we'll put them in the show notes for the YouTube recording, and then everybody can check out all of the vehicle shenanigans that you've got going on.
Love good questions and
very
shenanigans.
Cool. All right. Rob, as always, it's a pleasure hanging out and chatting with you. the next time we do it, it'll be like the first time we did it, with a couple of drinks in our hands and a lovely steak dinner somewhere in California. And other than that, thanks for coming on. This was super fun and informative, and helped me up my Terraform game significantly.
I am glad for it, Chris. It's been a pleasure, and really enjoyed it. So thank you, and I'll see you again soon.
All right, everybody, have a great night. We'll talk to you soon.